June 2024, a radio telescope array in rural Australia, scanning the Milky Way for transient signals, detects something that doesn't belong.
A dead NASA satellite is expected to crash into Earth's atmosphere today. It's not as scary as it sounds, though. Officials say the chances of the entire 600-pound satellite hitting the Earth itself are low.
Late today, NASA said that debris from a falling satellite could hit North America tonight.
A powerful burst of radio waves, sharp and bright, originating from within our own galaxy. The signal is strong, it's real, and it doesn't match any known astronomical source. Not a pulsar, not a magnetar, not a fast radio burst from a distant galaxy. The coordinates point to something much closer, something in Earth orbit. The astronomers trace the signal. They check the coordinates against every catalogued object circling the planet. And when the match comes back, the room goes very quiet, because the source of the signal is Relay 2, a NASA communications satellite launched from Cape Canaveral, Florida, on January 21, 1964. A satellite that went offline in 1967 after both of its onboard transponders failed. A satellite that has been drifting through orbit, dead, powerless, classified as space debris for 57 years. And it just sent a signal, not a faint whisper, not a degraded echo, a radio pulse so powerful that it was initially flagged by the detection system as a potential new astronomical discovery, a burst of energy coming from a machine that has had no functioning power system, no operational electronics, and no reason to emit anything since Lyndon B. Johnson was President of the United States. The researchers published their findings in a preprint study posted in June 2025, detailing what they detected and, more importantly, what they cannot explain. They proposed two possible mechanisms. The first is electrostatic discharge. As a satellite orbits Earth, it passes through regions of varying charge in the magnetosphere, the plasma environment, and shadow boundaries where sunlight suddenly cuts on or off. Over decades, charge can accumulate on surfaces and internal components. If that charge reaches a critical threshold, it can discharge violently, like a static shock, producing a burst of radio frequency energy. Essentially, the satellite got shocked by space itself and screamed. The second possibility is a micrometeoroid impact, a tiny grain of space dust, traveling at tens of kilometers per second, striking the satellite's surface hard enough to vaporize metal and generate a plasma flash that emits radio waves. A collision so small it wouldn't visibly damage the satellite, but energetic enough to produce a detectable signal across the electromagnetic spectrum. Karen Aplin, a professor of space science and technology at the University of Bristol, told New Scientist that either scenario is possible, but that it would be very difficult to establish which one applied, because the signals produced by both would look nearly identical. She called the detection a good launchpad for future investigation into electrostatic discharge from defunct satellites. But here's the thing nobody is saying out loud. Both explanations are hypotheses. Neither has been confirmed. And the signal from Relay 2 is not an isolated event. It's part of a pattern that has been repeating, quietly, for decades. Dead satellites coming back to life. Machines that should be silent, that have been silent for longer than most people on Earth have been alive, suddenly emitting signals that nobody expected and nobody can fully explain. And the most famous case is the one that started it all. February 11, 1965, Cape Kennedy, Florida. A Titan III rocket lifts off carrying a small experimental satellite built by MIT's Lincoln Laboratory for the United States Air Force. Its name is LES-1, Lincoln Experimental Satellite 1. Its mission is to test high-frequency military communication systems in space. But something goes wrong immediately. Due to what NASA later described as a miswiring of the ordnance circuitry, the satellite never reaches its planned elliptical orbit. It's stuck in a low circular orbit. It limps along for 2 years, accomplishing only a fraction of its objectives. And then in 1967, it stops transmitting, dead. Another piece of Cold War space junk circling the planet at 7.8 kilometers per second, joining the growing cloud of debris that humanity was already beginning to scatter across low Earth orbit. For 45 years, LES-1 said nothing. It orbited in silence, while the world below it changed beyond recognition. The Vietnam War ended. The Berlin Wall fell. The Soviet Union collapsed. The internet was invented. Smartphones were born, and LES-1 drifted overhead, dead, forgotten. a relic of an era when satellite technology was so new that the engineers who built it wore ties and used slide rules. And then, in 2012, an amateur radio operator in Cornwall, England, named Phil Williams, picked up something on his equipment, a signal, faint, pulsing, fading in and out on a 4-second loop. At a frequency of 237 megahertz, he traced it. He cross-referenced it with satellite databases. And when the identification came back, he realized he was listening to a machine that had been dead since before he was born. LES-1 was transmitting after 45 years of silence. A satellite from 1965, built with technology that predates the pocket calculator, was broadcasting a signal strong enough to be picked up by a hobbyist with a radio antenna in his garden. The Lincoln Laboratory confirmed the signal. A team of engineers set up a dedicated system at the laboratory's main campus in Lexington, Massachusetts, to record LES-1's transmissions every time the satellite passed overhead. And what they heard was haunting: a repeating pulse, regular, rhythmic, fading in and out as the satellite tumbled slowly through space, its solar panels intermittently catching sunlight. The laboratory's official explanation was careful. They wrote, "Though we don't know for certain why this zombie satellite came back to life, one possibility is that LES-1 experienced an electrical short caused by its batteries or circuitry degrading over time, allowing power from its solar cells to directly reach the transmitter." Read that again. They don't know for certain. After decades of silence, a satellite spontaneously began transmitting. And the best explanation the engineers who originally built it can offer is that something broke in just the right way. That decades of degradation, radiation exposure, thermal cycling between the burning heat of direct sunlight and the freezing cold of Earth's shadow, hundreds of thousands of times, somehow reconfigured the satellite's internal wiring, a failure that created a circuit where none was supposed to exist, a short that didn't destroy the transmitter but activated it. The satellite didn't come back to life because someone turned it on. It came back because something inside it broke. And the way it broke, by pure chance, by the accumulated damage of half a century, in the most hostile environment imaginable, happened to reconnect a power source to a transmitter in a configuration that its original designers never intended. And LES-1 wasn't the only one. In 1974, AMSAT Oscar 7, an amateur radio satellite, suffered a battery failure and went silent, dead for 21 years. And then, in 2002, ham radio operators around the world began hearing it again. The theory is the same. The failed battery eventually developed an open circuit, like a broken wire inside a dead cell, which allowed the satellite to run directly off its solar panels whenever it was in sunlight. No battery buffering, no regulation, just raw solar power hitting the transmitter whenever the geometry was right. Oscar 7 remains intermittently operational to this day, a satellite from the Nixon era, still talking, more than 50 years after it was built. In April 2010, a commercial communications satellite called Galaxy 15, operated by Intelsat, suffered a malfunction that knocked out its command receiver. The satellite stopped responding to ground commands. It drifted out of its designated orbital slot, but its transponders stayed on. It continued relaying signals autonomously, broadcasting without authorization, a ghost ship sailing through geostationary orbit, earning the nickname ZombieSat in news reports. 8 months later, in December 2010, Galaxy 15 spontaneously rebooted itself. Its onboard software reset. It started responding to commands again. Intelsat regained control. Nobody could explain what caused the original failure or what triggered the recovery. 3 satellites, 3 different decades, 3 different failure modes, and in each case the same pattern. A machine that should be dead, that was declared dead, that was written off and forgotten, suddenly begins emitting signals from orbit. Not because someone repaired it, not because ground controllers sent a wake-up command, but because something, deep inside the decaying circuitry, in the slow atomic rearrangement of metals and insulators subjected to decades of cosmic radiation, thermal stress, and micrometeoroid bombardment, shifted, changed, reconnected. And here's where the story goes from strange to genuinely unsettling. There are currently more than 3,000 defunct satellites orbiting the Earth, alongside an estimated 36,000 pieces of tracked debris larger than 10 centimeters and millions of smaller fragments. Every one of those dead satellites contains electronics, circuit boards, wiring, capacitors, solar cells, transmitters, receivers, components designed to operate in the vacuum of space, built to withstand radiation and thermal extremes, sealed inside housings meant to last for years. But years and decades are different timescales, and what happens to electronics left in space for 50 or 60 years is not well understood. The radiation environment in orbit degrades semiconductor materials in ways that are difficult to predict over very long timescales. Thermal cycling, swinging between extreme heat and extreme cold every 90 minutes for decades, creates mechanical stress that can crack solder joints, warp circuit boards, and cause unexpected connections between components that were never meant to touch. Atomic oxygen in low Earth orbit erodes surface coatings. Micrometeoroid impacts punch microscopic holes through shielding, and cosmic rays, high-energy particles from deep space, can flip individual bits in memory chips and create transient electrical currents in circuits that haven't been powered in decades. The result is that a dead satellite in orbit isn't static. It's changing, slowly, constantly. Its internal structure is being rewritten by the environment, and over a long enough timeline, the probability that some random reconfiguration produces a functional circuit, even briefly, even weakly, isn't zero. It's small, but it's not zero. And with thousands of dead satellites overhead, each one undergoing this slow, random transformation for decades, the probability that at least one of them does something unexpected in any given year starts to become significant. What the Relay 2 detection suggests is that this process may be more common than anyone realized. The researchers noted that their finding has implications for the growing problem of space debris. If defunct satellites can spontaneously emit radio signals, those signals could interfere with active communication systems, confuse radio astronomy observations, or trigger false alarms in systems designed to detect threats. Aplin noted that in a world with increasing numbers of small, low-cost satellites with limited protection from electrostatic discharge, this kind of detection becomes increasingly relevant. And there's a deeper, more philosophical dimension to this that scientists don't typically address in their papers, but that hangs over the entire phenomenon like a question nobody wants to ask. We built these machines, we launched them into space, we used them, we turned them off, we forgot about them, and decades later they started talking again. Not because we asked them to, not because they were designed to, but because the universe, through the slow, patient, random application of radiation, heat, cold, and impact, rearranged their insides until a signal came out. There's a word for a system that reorganizes itself over time in response to environmental pressures until it produces a functional output. The word is uncomfortable when applied to a machine, so scientists don't use it. But the pattern is there. Dead circuits, subjected to decades of environmental forcing, occasionally producing coherent signals from configurations their designers never planned. LS1 has been transmitting its ghostly 4-second pulse since 2012. That's 14 years. 14 years of a satellite from 1965, built with vacuum tube-era technology, broadcasting from orbit on a circuit that was never designed to exist, powered by sunlight hitting solar cells that were meant to last 3 years. Oscar 7 has been intermittently active since 2002. 24 years. A satellite from 1974, running on raw solar power through a broken battery, still audible to amateur radio operators around the world whenever its tumbling body catches the sun at the right angle. And now, Relay 2. Silent since 1967. 57 years. Then a single, powerful radio pulse, strong enough to be mistaken for an astronomical event, fired from a satellite that has no working power system, no functioning electronics, and no business making any sound at all. The engineers have their hypotheses: electrostatic discharge, micrometeoroid impact, degraded wiring creating accidental short circuits, all plausible, all reasonable, all incomplete, because the honest answer, the one that sits beneath every carefully worded explanation, is the one that Lincoln Laboratory itself admitted when LES-1 came back. We don't know for certain. 3,000 dead satellites are circling the Earth right now, tumbling, degrading, changing, being slowly rewritten by the environment of space. Most of them will stay silent forever, but some of them, on timescales that exceed the careers of the people who built them, will do something unexpected. A signal, a pulse, a transmission from a machine that should have nothing left to say. And when it happens, when a radio telescope picks up a signal from a satellite that's been dead longer than most humans have been alive, the question isn't really about wiring or electrostatic discharge. The question is simpler and harder. What does it mean when something we built, something we abandoned, something we left for dead in the coldest, most hostile environment we've ever placed a human object in, refuses to stay silent? The satellites don't know they're dead. They don't know they've been forgotten. They just orbit, and sometimes, after decades of silence, something inside them shifts, and they speak. Nobody told them to. Nobody can explain why, and nobody can promise it won't happen again.